Okay. So the first one we're going to look at is talking about using the TI-84. The main thing that I want you to understand is that you've already written down all the steps using it. The only thing that we're adding is to turn on our R² value and not just using linear. Okay. All right. So our TI-84, we've already talked about regressions with linears, correct? Well, you also can do regressions with your quadratics and exponentials. Okay. We've already gone the whole time on linear. We're all good, right? Doing it. Now we're going to talk about with quadratics and exponentials. Okay. I don't have notes. I didn't. Oh, they're in the paper we need is on the copier next door. I'll go grab it in a second. Okay. The main thing that we're going to be doing is changing our settings. So the key thing here is there's a new feature that we want to be able to turn on, and that's our R² value, where it tells us what it is. In order to turn that on, we're going to press mode. We're going to float, and then we're going to turn on our stat diagnostics. The reason why we're going to have it float is just so that we're now rounding to 3 nearest decimal places. Okay. So I'm going to grab my calculator screen. I'm going to clear my calculator. Second plus, I don't know what I've been doing with this calculator. And now I'm going to go to mode. I'm going to change my float to 3. And I'm going to go down here where it says stat diagnostics, and I'm going to turn them on. So where it says stat diagnostics, I turn them on. That's all we've done so far. And then at this point, we're going to make our way to stat calc. And whether you're using, well, we got to put the information in it, but whether you're using linear, it's going to be 1, quadratic, it's going to be 5, and then exponential is going to be, it is not 1, it is 4. You saw nothing. I'm going to grab the paper so we can test out the process. Cool? All right. So I'll give you a moment, but the new things, we already know the other steps. Stat, edit, input, we already got that, right? That's why we're not repeating writing those steps. That's why your do now was recall how to do a regression, okay? All we're doing is adding in the rounding, the auto rounding, and looking at the diagnostics. Got it? Everything else is in your brain, I promise you. Let me go grab the paper that you need. We're not using this notes. We're not doing these notes yet. It just already had tables on it, so it's easier to use tables that are already created. Friends, I got your tables. These are notes for Friday, but we're going to use the tables that are on it. Does that make sense? Huh? No, not right now. It will be. Sorry. Right. All right. So do you guys see? You're welcome. Ignoring what the table says it is, we're going to just use these values so that we can model with it, okay? All right. So we're going to input the values in table 1 on the notes I handed you. We're going to put those values in. Did I never press pause? So we're going to go to stat, edit. And again, we're putting in the values on table 1. Okay, on example 1, table 1. And so my values are 0, 1, 2, 3, 4, 5. Then we're going to put in 0, 3, 12, 27, 48, and 75. All right, so you notice here that our, because we put our mode into 3, it added extra zeros. We see that? Okay. Are we all comfortable with stat edit? They're right here. Oh, yeah, example 1. We're only using this for the tables, right? These notes are for when? Friday, okay? But I didn't want to have to reinvent tables. So I was like, oh, I'll print them early and we'll use those tables. Sound like a good idea. And I reorganized my notes, so their numbers and everything are changing. All right, so here we go. Our data is in. We turn on our statistics. Now we're going to test out linear, quadratic, and regression models, okay? So when I go to stat, I'm going to go to calc, and I'm going to test out the linear model first, okay? Linear model is there by pressing 4. So I press 4, and I just want it to calculate a linear model. Notice that now they have a R² value for me. Do y'all see that? 0.921. That's because we turned on those diagnostics. Does that make sense? So it turned on our diagnostics for us. So we now know that our R² value is 0.921. Okay, we're going to write that down. So for linear, we got 0.921. Okay, now we're going to do the same thing, but this time we're going to test out the quadratic. So we're going to go back to stat, calc, and we're going to go to 5 for quadratic. We put in the quadratic. We're going to calculate. And what is the R² value for quadratic? 1. Oh my gosh. Shocker. Okay. And we're going to find the R² value for exponential, just so that we can see. To get to exponential, you either can press 0 or you can scroll down to 0. Either way. And we're going to calculate. And its R² value is, what does it say? Error is not even worth it, right? Exponential is definitely a womp, 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 not applicable. Okay, so can someone tell me in conclusion, what is the R² telling you? What is that number telling us? Why? It's the residuals, but it's telling us how well the data fits this model, right? How well the model fits the data. So if it's at 1, that's 100% fit, right? So between these two, clearly, even regardless of the fact that we know it's a quadratic because we took it from the table, but we can clearly see with the data that a quadratic is 100% the best model for that information. Make sense? You can see that linear, it could work, but quadratic is the better model. And that's how that value is utilized. Okay? How do we feel about using stats on the calculator to determine if it's a good fit? Was it terrible? No, it wasn't. Okay? All right, the next one is using Desmos to do the same thing. Again, not the world's biggest fan of Desmos because I'm a little old school, but we're going to talk about on Desmos. But on Desmos, you have to write in your weird little squiggles. So before we go to Desmos, I would like for you to write down your regression models for Desmos, okay? When you are writing, it has to be written exactly how you see it, okay? So you're writing down your regression models for Desmos. And then we'll practice on Desmos. Make sure you have the rules written for Desmos. Okay. Are you ready for me to move into Desmos land? Yeah? Oh, no? Oh, I'm sorry. I thought you said yeah. I didn't hear the no. Okay. I said nothing. I said nothing. All right. So, Desmos again isn't a click of a button. It is remembering the models so that the algorithm follows it correctly. So I'm going to go to my Desmos. Hello, Desmos graphing. I have it saved on my bookmark bar. You gotta be quick, fast with it. So remember to input a table. So we're going to input a table, add a table. This time we're going to do it box number 2. We're going to use box number 2, example number 2, and we're going to input those values. So we have 0, 1, 2, 3, 4, 5. And then we have 1, 3, 9, 27, 81, and 243. We talked about it before that you may not be able to see your points. So you need to adjust your window. Adjusting your window, you can pull, and then you also can click the little tool button here and change your values. So my X's go up to 5. That's fine. I can make it 10. And my Y's go up to 253. So I'm going to put that at 250. And now that I've made those adjustments, I should be able to see my points, and then I can modify my zoom from there. Okay? It's a computer. It's smart. Let it be your friend. Don't let it intimidate you. Okay? All right. So clearly we have eyes, and we know that this is probably a exponential model. It's okay. We're going to pretend that we don't know that. We're going to find the R squared values to see if the R squared values represent that. Okay. So first we're going to start with the linear model. With the linear model, you're typing in y1 tilde mx1 plus b. Okay. So here's my R squared value. It's pretty low, right? Yeah. Okay. All right. I'm going to test out the quadratic. So for the quadratic, y1 tilde a x1 shift 6 to square. That is not an X. Arrow over, plus bx1 plus c. Isn't that what you wrote down? You type exactly what you wrote down. So yes.
My graph looks like way different than that one.
You changed the window.
I adjusted my window.
Oh, I see, yeah.
Yeah.
Two.
Shift 6.
Oh, 6.
Yeah, shift 6 gives you a power. And then arrow over from there. Okay. All right. Looking at the R squared value, not bad, right? It's pretty decent. Compare it to the linear. And then exponential, y1 tilde. And then what do I type? So that we all know where I'm coming from. What did you write down? What's next? Anybody, everybody? Nobody? All right, so that you know where I'm getting the numbers from. Remember, it's coming from here. So I'm typing A, B, and shift so that my X can be the power. Shift 6, okay? That's why I said make sure you write those down so that when we get to it, you're good. So A, B, shift 6, X1. And what do you notice about this R squared value? It is a 1. Oh my gosh, it's a perfect fit. Who would have thought? Okay, how it feel about using data points, given data points, determining the best fit between linear, quadratic, and exponential using technology.
It's been more complex than I thought.
But still doable? Yeah? Anyone's like, never. All right, so we're analyzing the what value again? The R squared. We're looking at the R squared to see if it's a good model or not. Got it? All right, perfect. So what you're going to do is you have a little assignment on Canvas. It's going to be a fill-in PDF, so you should be able to type out your stuff. I hope it works. I uploaded it as a fillable PDF. Fingers crossed that it goes smoothly. Hold on to them for Friday. There are notes for Friday. We just needed to utilize the tables. So you can put them in your handy dandy folder.